Hello friends, welcome to Daring Marine YouTube channel. Today we will be discussing about ship bulkheads and the types of ship bulkhead. Okay, let's discuss in the topic in detail way. The purpose and types of ship bulkhead. The bulkhead is an upright wall within the hull of a ship, which separates the hull into different rooms and compartments. Bulkhead, it is an upright wall within the hull of a ship. They will separate hull into different rooms and compartments. Okay. The purpose is to increase structural rigidity of vessel, limit flooding by preventing loss of buoyancy, divide functional areas into rooms and compartments, prevent spreading of fire. Their function is to increase structural rigidity of vessel, limit flooding by preventing loss of buoyancy, divide functional areas into rooms and compartments, prevent spreading of fire. The types of bulkhead. Bulkheads are of different types according to their purpose, position, or construction. So there are different types of bulkheads. They are longitudinal bulkhead, transverse bulkhead, plain bulkhead, corrugated bulkhead, watertight bulkhead, non-watertight bulkhead, collision bulkhead, and thermal bulkhead. There are different types, mainly of the purpose, position, or construction. Here we can see on the basis of position, they are divided into longitudinal bulkhead and transverse bulkhead. Based on the position, they are divided into longitudinal bulkhead and transverse bulkhead. Based on the construction, they are divided into plain bulkhead and corrugated bulkhead. Based on the position, on the construction, they are divided into plain bulkhead and corrugated bulkhead. Based on watertight capability, they are known as watertight bulkhead and non-watertight bulkhead. Based on thermal, they are divided into class A bulkhead, class B bulkhead, class C bulkhead. From the thermal bulkheads, they are divided into three, that is class A, class B, class C bulkhead. Special purpose are known as collision bulkhead and insulation bulkhead. These are special types of bulkhead. Okay, these are the kinds of bulkhead and all. So let's discuss about watertight bulkheads. This kind of question we need to understand. So watertight bulkhead. The main function of watertight bulkhead is to divide ship into watertight compartment and thus restrict volume of water which may enter ship if shell plating is damaged. Most watertight bulkhead are transverse in orientation. Some ships also have longitudinal watertight bulkhead. Main function of watertight bulkhead is to divide ship into watertight compartment, thus restrict volume of water which may enter ship if the shell plating is damaged. Most watertight bulkhead are transverse in orientation. Some ships also have longitudinal watertight bulkhead. This serves to separate different form of cargo to decide tanks and machinery space from cargo space. This serves to separate different of cargo and to decide tanks and machinery space from cargo space. In case of fire, they will reduce the rate of fire spread. This bulkhead. Then it will also have a strengthening member, so it will increase the strength of ship. So main function of watertight bulkhead is to divide ship into watertight compartment, thus restrict volume of water which may enter ship if shell plating is damaged. Most watertight bulkhead are transverse in orientation. Some ships also have longitudinal watertight bulkhead. They serve to separate different of cargo and to decide tanks and machinery space from cargo space. In case of fire, they will reduce the rate of fire spread. They will strengthen the ship. Longitudinal girders and deck longitudinal are the supporter at the bulkhead, which therefore act as pillars. Longitudinal girder and deck longitudinal are supporter at bulkhead, which therefore act as pillars. At the same time, they tie together the deck and the tank top, hence reduce vertical deflection when compartments are full of cargo. At the same time, they tie together the deck and tank top and hence reduce vertical deflection when compartments are full of cargo. The plating of transverse bulkhead usually consists of series of horizontal strakes that are welded together. The plating of transverse bulkhead usually consists of series of horizontal strakes that are welded together. The thickness of the strakes increase with the depth in order to strengthen the bulkhead against maximum hydrostatic pressure in case the compartment is fully flooded. The thickness of the strakes that will increase with the depth in order to strengthen the bulkhead against the maximum hydrostatic pressure in case the compartment is fully flooded. The number of transverse bulkhead in a ship is dependent upon length of ship. The number of transverse bulkhead that is used in a ship depend upon length of ship. However, all ship must contain a collision or forepeak tank bulkhead, and after-peak tank bulkhead at each end of engine room. Okay. The watertight doors and the testing that we need to do. So watertight doors and their testing. If watertight doors are made to use them as accommodation or machinery space, they are provided with watertight doors for safe access. Such as opening must be cut only when necessary for the use of safe working of ship. Okay. If watertight bulkhead are made to use them as accommodation or machinery space, they are provided with watertight doors. So for watertight bulkhead, they will be having watertight doors for safe access. Such opening must be cut only when necessary for the use of safe working of ship. There are mainly three types of watertight doors. Vertically mounted watertight doors. They are mild or cast steel doors. It can be opened vertically or horizontally. That means vertical sliding door or horizontal sliding door. The means of opening must only rely on gravity. Vertically mounted watertight door means these are made of mild or cast steel doors, and it can be opened vertically or horizontally. Vertically sliding door and horizontally sliding door. This means of opening must only rely on gravity. And hinged watertight door. Hinge these may be fitted in watertight bulkhead in the passenger ship above 2.2 meter more or above water line. This type of doors, hinged watertight door, may be fitted in a watertight bulkhead in passenger ship above 2.2 meter or above load water line. These are generally heavy doors that when closed seal on packing material that is welded to the door frame with the help of metal strip. Okay, these are heavy doors that when closed seal on the packing material that is welded to the door frame with help of metal strip. Automatic operating watertight door. Automatic operating watertight door. This system is used in case if there is fire or flooding. In such situation, a signal is sent from the bridge or engine room to an oil diverter valve. The door is operated with help of pressurized hydraulic oil, which moves the ram that controls opening and closing the door. Automatic operating watertight door means this system is used in case there is a fire or flooding. In such situation, signal is sent from bridge or engine room to an oil diverter valve. The door is operated with the help of pressurized hydraulic oil, which moves the ram that controls the opening and closing of the door. Initial test of watertight door as per SOLAS. So, initial test of watertight door means in passenger ship, watertight doors shall be tested by water pressure to a head up to the bulkhead deck or freeboard deck. In cargo ship, a hose test is also acceptable. So, what are the initial tests as a for watertight door that may be done as per SOLAS means in passenger ship, the watertight door shall be tested by water pressure up to head up the bulkhead deck or freeboard deck. In cargo ship, an hose test is also accepted. Then plain bulkhead and corrugated bulkhead. So let's discuss about the plain bulkhead and corrugated bulkhead. According to construction, there are two types of bulkhead. They are plain bulkhead and corrugated bulkhead. Okay, plain bulkhead. It consists of plates that are stiffened by rolled section, such as bulb plates and angled space approximately 76 mm, 760 mm apart. Okay, that means plain bulkhead. This consists of plates stiffened by rolled sections, such as bulb plates and angled space approximately 760 mm apart. Thickness of plates are generally thickest at bottom because of maximum hydrostatic pressure experienced there. So, thickness of the plates are generally thickest at bottom because of maximum hydrostatic pressure, and thinnest at the top, generally not less than 6.5 mm thick. So, they are thinnest at the top, generally not less than 6.5 mm thick. The plates of bulkhead are laid in horizontal direction. You have to understand that the plates of bulkhead are laid in horizontal direction. Where the depth of bulkhead is great, then horizontal stringers or girders are fitted, as well as vertical girder with face plates and tripping brackets. So, we have to understand that the depth of bulkhead is great and horizontal stringers or girders are fitted, as well as vertical girders with face plates and tripping brackets. So, plain bulkhead means it consists of plates stiffened by a rolled section, such as bulb plates and angled space approximately 760 mm apart. Thickness of the plates are generally thickest at bottom because of maximum hydrostatic pressure experienced there, and thinnest at the top, generally not less than 6.5 mm thick. The plates of bulkhead are laid in horizontal direction. Where the depth of bulkhead is great, horizontal stringers or girders are fitted, as well as vertical girders with face plates and tripping brackets. Then corrugated bulkhead. Corrugated bulkhead. This plate is stronger than flat plate. It is subjected to bending moment or pillar load along the corrugation. This corrugated plate is stronger than flat plate if subject to bending moment or pillar load according to corrugation. Corrugation or swedges are formed on corrugated bulkhead to eliminate the need to fit the vertical stiffener, as those in case of plain bulkhead. Corrugation or swedges are formed on corrugated bulkhead to eliminate the need to fit the vertical stiffener, as in those of plain bulkhead. Corrugated plate, it is stronger than flat plate without stiffening if subject to bending moment or pillar load along the corrugation. Corrugated plate is stronger than flat plate without stiffening if subject to bending moment or pillar load along the corrugation. Elimination of vertical stiffener also results in saving steel weight and cost of stiffener. Elimination of vertical stiffener also results in saving in steel weight, that means cost of stiffener. Angle of corrugation is normally about 45 degrees. Angle of corrugation is normally about 45 degrees. Corrugated bulkhead means this corrugated plate is stronger than flat plate, is subject to bending moment or pillar load along the corrugation. Then corrugation or swedges, these are found on corrugated bulkhead to eliminate the need to fit the vertical stiffener as those in plain bulkhead. Corrugated plate is stronger than flat plate without stiffening if subject to bending moment or a pillar load along the corrugation. Elimination of vertical stiffener also results in saving in steel weight and cost of stiffness. The angle of corrugation is normally about 45 degree. The trough are vertical on transverse bulkhead. The trough are vertical on transverse bulkhead, but must be horizontal on continuous longitudinal bulkhead. Which form part of longitudinal strength of ship. This form part of longitudinal strength of ship. Okay. Diaphragm plates or horizontal hinges. Diaphragm plates or horizontal hinges are fitted on bulkhead to keep the corrugation in place. Okay. The troughs are vertical on transverse bulkhead, but must be horizontal on continuous longitudinal bulkhead. This forms part of longitudinal strength of ship. And the diaphragm plates or horizontal ridges are fitted on bulkhead to keep the corrugation in place. So let's discuss about collision bulkhead, their purpose and solace regulation and position and all. Collision bulkhead. Okay. Collision bulkhead, it is a heavy duty watertight bulkhead in the forepart of vessel to withstand damage after impact from collision. Collision bulkhead, it is a heavy duty watertight bulkhead in the forepart of vessel to withstand damage after impact from collision. It is the foremost major watertight bulkhead. Which extends from bottom to main deck or upper deck. It is the distance of L/20 from forward perpendicular. Solace regulation, that means Solace chapter 2 regulation 12.1. Okay. The bulkhead is a watertight from the bottom of ship up to main deck. Up to the main deck. Collision bulkhead should be located not less than 0.05 length or 10 meters. Whichever is lesser from the forward perpendicular. Not more than 0.08 L or 0.05 L plus 3 meter. Whichever is greater from the forward perpendicular. Minimum, like I mentioned, 0.05 L or 10 meter diameter. Or maximum should be 0.08 L or 0.05 L plus 3. Collision bulkhead should not have any opening like doors, manholes, access opening, ventilation duct, etc. Collision bulkhead should not have any opening like doors, manholes, access opening, ventilation duct, etc. Single pipeline is allowed to penetrate through the collision bulkhead for filling and emptying the forepeak tank. We can have single pipeline is allowed to penetrate through the collision bulkhead for filling and emptying of forepeak tank. Why the collision bulkhead is kept at L/20 of a ship, that means length by 20 of a ship? The position of bulkhead depends upon some factors. One reason is solace regulation. Like I mentioned before, it should be minimum 0.05 length and maximum should be 0.05 L plus 3 meter. Okay. Then another is classification society requires a watertight collision bulkhead within reasonable distance from the forward. So as per classification society, it requires watertight collision bulkhead within a reasonable distance from the forward. Position based on floatable length calculation. By truckoidal theory, wave height from trough to crust is 1/20 of wavelength. Therefore, maximum shearing force usually occurs as L/20 of ship from each end. By truckoidal theory, wave height from trough to crust is 1/20 of wavelength. Therefore, maximum shearing force usually occurs at L/20 of ship from each end. Okay. Thank you.